Hello everyone, welcome to Introduction to Data Mining class. In this unit, we will introduce classification evaluation matrices, including precision, recall, and F-measure. To evaluate a binary classification results, precision and recall are two commonly used evaluation metrics. As you can see on the left of the screen, all small dots represent data object, where the dark dots represent one class and the white dots represent another class. Assume the dark dots represent the class relevant to our search, and the white dots represent the class irrelevant to our search. A classification algorithm can be used to predict the class label for each data object, and thus, we may have the following four outcomes. A dark dot is predicted as a relevant object. A dark dot is predicted as an irrelevant object. A white dot is predicted as a relevant object. A white dot is predicted as an irrelevant object. When a classification algorithm is correctly predict a dark dot as a relevant object, it is considered as true positives as shown in green. When the classification algorithm is incorrectly predict a dark dot as an irrelevant object, it is considered as false negatives as shown on the dark dots outside of the circle. When the classification algorithm is incorrectly predict the white dot as a relevant object, it is considered as false positives as shown in red. When the classification algorithm is correctly predict a white dot as an irrelevant object, it is considered as true negatives as shown on the white dots outside of the circle. The precision is defined as true positives divided by the all selected items, which describes how many selected items are relevant. The recall is defined as true positives divided by the all relevant items, which describes how many relevant items are selected. An algorithm with a high precision value and a high recall value indicates good performance. The precision and recall can be plotted as a precision recall curve to compare the performance of classification algorithms. As illustrated in the plot, x-axis represents the recall, while the y-axis represents precision. As you can see, when the precision of an algorithm is getting higher, the recall of the algorithm is typically getting lower. Therefore, it would be better to combine the precision and the recall into a single measure for performance comparison. F-measure, also known as F-score, is a measure to consider both precision and recall. The F-measure is defined as the harmonic average of the precision and recall, which produce a single measure between 0% and 100%. Higher F-measure indicates better performance.